Hi, in this video I'm going to do a quick review of logarithms. So basically a logarithm is a way of taking a big number and replacing it with a smaller number. In this class we're only going to work right now with the log base 10, okay? And so we'll write log base 10 like this, log. So suppose I take log, it's a function, and then I apply it to some number, say 10. What's that equal to? Well, it turns out we can always write that number in parentheses as 10 is the same as 10 raised to the power 1, right? So this ends up being equal to this, 1. Now, what you can see here is when you take a log of a number, it takes a bigger number, replaces it as a smaller number, and when it's log base 10, the number that it returns is the number that you would raise to power 10 to get back the original number, right? So if I take my 10 and I raise it to power 1, then I just get back my original number, 10, right? Let's look at another example. Log of 100. Guess what that might be? Well, this is an easy example because we know that we can write 100 as 10 squared, 10 times 10, and therefore this must be equal to 2, right? And of course we can go check, take the log of that number, raise it to power 10. Do we return the original number? We do. Good. Let's try a different one. This one we can't do in our head, but the log of 50. What number do you think this is going to be close to? Probably somewhere in between 1 and 2, right? But to actually get this, you got to go to your calculator, use your log base 10, and if you put it in, you'll get this, 1.699. What does that mean? Well, it means that if I take 10 and I raise it to exponent 1699, I'm going to get back 50, right? So this all tells us actually a way to do an inverse function, right? So how do I do an inverse function for log? For example, say that I have log 50 and I want to remove the 50 from the parentheses, right? How do I do that? Well, I know that if I raise this number here, right, to base 10, I'm going to end up getting 50. So if I raise this number here, oops, right like this. Let me go back for a second. So if I raise this number here to base 10, so 10 raised to the power of log 50, right, we know that this is 50. So what this does is it just brings down the original number. And you know, it makes sense, right? Finally, say we have an equation, something like this. Log of x is equal to, say, 3.2, right? How do we solve for x now? Well, we do what we just did here. We got to use the inverse function, right? I can go ahead and raise both sides of the equation to base 10, and I know that that's going to remove the x from the parentheses, bring it down, right? And of course, this is good algebra. We got to do the same operation to both sides, and so now we've just solved for x. X is equal 10 to the 3.2, right? And if you go ahead and stick that in your, we find out that this is equal to about 1,585. And so the fact that we've got 3 here in the exponent makes a lot of sense because we've got 3 digits there, 3 powers of 10 in that number.